Hi everyone. So we really struggled with the optimization quiz, which I set in class. So instead of doing some of the ones from your packet, I figured I would just make a video answer key for the optimization quiz because we didn't really go over them as a class when I gave them back today. So these two examples hopefully will make sense after this video. Find the maximum volume of an open box that can be made by cutting out congruent squares from the corners of an 8 by 15 rectangular sheet of cardboard and folding the sides. So this is what we did in class. This is also, I think, the first example in the optimization video, but I'm going to go ahead and do it again to just kind of go through it. So first step, guys, is to draw a picture of what's going on. So we're cutting these square corners out. And each of these corners is x. It's not quite proportional, it's not quite, or congruent. I don't really care, guys. It just needs to be a rough sketch of what's going on. Alright, and this was an 8 by 15 inch rectangular sheet. So that means now that this distance is now 15 minus 2x, and this distance is 8 minus 2x. Okay, and when we fold those sides up, the height is now x. So we're trying to find the maximum volume. That's the key word there, guys, volume. All right, think about how we find the volume of a rectangular prism, and we wrote this in our useful formulas. But the volume is equal to the length times the width times the height. We need all three values. Okay, well, the length and the width, it doesn't matter which one you label which, but that's the 15 minus 2x and the 8 minus 2x. So we're going to have 15 minus 2x times 8 minus 2x, and the height of our box is just x. It's whatever we cut off and fold up. Okay, so that's our volume equation. But to take the derivative of that, we're going to want to multiply everything out. So let's see what we get. 15 times 8, so that's really 30 times 4, so 120. And then we get minus 30x minus 16x plus 4x squared. And that's all in parentheses and being multiplied by x. So we get that the volume is equal to, I'm going to distribute, combine like terms, and rearrange all in one. But we get 4x cubed minus, let's see, that becomes 46x squared, and then plus 120x. So this is our volume formula. Now we've got a detailed picture, we've got a formula that's all in terms of one variable, and now we can take the derivative. So v prime is going to equal 12x squared minus 92x plus 120. And we're going to go ahead and set this equal to 0. All right, now let's see. We can divide all of those by 4. So I'm going to go ahead and do that. And I'm going to be left with 3x squared minus 23x plus 30. And we can technically factor that. So we'd have 3x and x, and let's see, 30 can be a 5 and a 6. So, oh, I just lost my train of thought. Sorry. This is my minus 5, this is my minus 6. Right? Negative 18 minus 5 is negative 23. Okay, we're good. Whew. So if I set these equal to 0, then I get that x is equal to 5/3 and that x is equal to 6. So I got two answers here. But we have to think about what we're doing. So if I'm cutting these squares that are this length of x, I have to think about if these make sense. So this side here was only 8 inches to begin with. If I cut squares of 6 inches off of each side, that's going to give me a negative length here, which means this isn't going to work. This is too long. But the 5/3 will end up working out. If you want to go ahead and write yourself a reminder here, we know that x has to be greater than 0, right? and it's going to have to be less than 4. Because if I made it 4, that would be like cutting this exactly in half, and I wouldn't have any width there anymore. So it needs to be somewhere between 0 and 4, and we know that 5/3 is. Now you have to pay attention to what the question is asking you. It says find the maximum volume. It doesn't ask for the dimensions. So what I need to do is take this 5/3 and I'm going to plug it into my volume formula. So volume is equal to 4, and then it's x cubed minus 46 x squared plus 120 x. So that's my 5/3. And I did tell you guys at the end then that you could use your calculator. So we end up getting that the volume is equal to 90.741 inches cubed. But everything up to here you should have been able to do without a calculator. All right, so don't rely so much on your calculator. You're not going to be able to use it on the AP exam. Okay, question 2. We have a rectangular page that's to contain 24 inches squared of print. That's an area, guys, just FYI. The margins at the top and the bottom are 1.5 inches. The margins on each side are 1 inch. What should the dimensions of the entire page be so that the least amount of paper is used? So we did an example like this together. We did question 3 from your practice because this is a more difficult one. So what we're really looking at here is we're looking at whatever this picture is, all right? We don't know exactly what it is, but we know that the area of it is 24 inches squared. Okay, the dimensions of it we don't know. I'm just going to call them X and Y. But it's some type of picture, okay? Then I have margins at the top and the bottom that are 1.5 inches and margins at the side that are 1 inch. So really, I'm just going to go ahead and draw around it. And it doesn't have to be perfect because I'm going to label what each of these is. Well, let's see. Bottom and top is 1.5 inches. So this is 1.5 inches. This is 1.5 inches, right? Top and bottom. And then the sides are 1 inch. Okay, so if I look at the dimensions of this paper then, it was X and I added 1 inch on either side. That means now this entire distance is X plus 2. Okay, and then the height here, it was Y and I added 1.5 inches, so this is now Y plus 3. Alright, so this is what my picture kind of looks like. And I know that my original area of this purple picture, whatever it is, was 24 inches. And I know that area is equal to X times Y. So I get 24 is equal to X times Y. Okay? But we're looking at the dimensions of the entire page. That's this X plus 2 by Y plus 3, whatever this thing is. Okay, it's this whole purple thing around it, including the 24 inches squared. So we need to look at the area of that whole thing, which is X plus 2 times Y plus 3. I don't know what X and Y are, but I know I added 1 inch on either side and 1.5 inches on the top and the bottom. So I think what confuses students here is that these are both area formulas, because a lot of students set the 24 equal to this, and that's not correct. 24 is this area inside. This area is talking about the area of the whole thing. All right, so let's go ahead and solve one of these, or solve for one of these variables. So I think when I did it, I solved for y, and I said that y is equal to 24 over x. So I'm going to go ahead and take that and substitute it in for y. So now my area, all in terms of x, is x plus 2 times 24 over x plus 3. And I'm going to go ahead and multiply that out before I take the derivative because it's easier. So let's see, that becomes 24 plus 3x plus 48 over x plus 6. So my area in terms of x is 3x plus 48 over x plus 30. All right, now I have one equation that's all in terms of x, and I can take the derivative. This is what I'm trying to minimize, right? I'm trying to find the dimensions of the entire page so that the least amount of paper is used. So I want to find the minimum value of this function. So to do that, I find a prime. So I get 3. Remember, this is the same as 48 times x to the negative first. So negative 48 over x squared, and the derivative of 30 is 0. So now I'm going to set that equal to 0 and start to solve. So I get 3 is equal to 48 over x squared. If you need to put a 1 there, put a 1 there, and we're going to cross multiply. All right, so we get that 3x squared is equal to 48. So x squared is equal to 16, which means that x is 4. Now technically it would be negative 4 as well, but we're talking about the picture here, so it can't be negative. But we get that x is equal to 4. So we can go back to this equation here, and we can plug that in. So 24 over 4, we get that y is equal to 6. But what we have to remind ourselves is that x and y are the dimensions of the picture that we're printing. We want the dimensions of the entire page of paper. So for the picture, it would be a 4 by 6, but we want the dimensions of the paper, which means we want x plus 2. So since x was 4, that's going to be 6 inches. And then this is y plus 3. So since y is 6, that would be 9 inches. So that was the final answer there. Okay, I hope it's making a little bit more sense. You've got tons more optimization practice if you want to redo some of those problems or come in and see me for some help. But we got to get this figured out. This is a big deal for later on. So ask questions, all right? See you later.